At this point in the course, I want to pause for a moment and think about how we check whether the code we write works. All the time we're writing code and conditional logic and things like that, but how do we actually know that what we write does what we intend? Consider the logic we've just written, that the button should be enabled or disabled, depending on whether or not we have any input. And the way we go about checking that, quite simply, is by running the app and having a play. We write the code. Our intention is that when there's no input, you can't press the save button, so we run the app, open the dialog, and we confirm, yes, the button doesn't work. We check it, make sure. We put some characters in. We see that the save button works. We might give it a click, make sure we can still add tasks. We can delete that. We try again, add some characters, and then delete them, and make sure that the save button doesn't work. We can see it's disabled, but we might also click it to make sure, just in case it changes the visuals, but the button still works. These are all mini little tests that we're doing ourselves in the app. And so I want us to think about what testing really is. In your journey into Android software development, you may have, or you may have not, already heard of the term testing as being quite a big deal in the software engineering world. But I myself remember when I was a junior Android engineer hearing about testing, but not really understanding what it was. I thought I knew what it was, because I was writing some code, running it, and testing my app to make sure it worked, checking it, playing with it. But then I heard some more complicated terms like unit testing and integration testing and some quite complex concepts. And so I believed that I didn't actually really know what testing was. And in the next tutorial, we're going to do a deep dive into the concept of testing to see the different kinds of testing there are. But I'm here to tell you right now that when you write some code and when you run the app to check that it works, that is testing. Specifically, it's manual testing. You are testing it manually yourself, you're running the app, and you are probably running through, in your head, a series of test cases. Case 1, when I open the dialog, the button should not be enabled. Case 2, when I start to type, the button should become enabled, and so on. And so this is manual testing, and it is completely valid, and indeed it plays a big part in real companies as part of their testing flow, as part of their quality assurance to make sure that the apps behave as they're supposed to. There will often be a team of manual testers who will do exactly this. So let's have a play then. We know that the button starts off disabled, we know that it becomes enabled when we start to type, we know that it becomes disabled when we remove the characters again. But let's try some different scenarios. I'm going to hit the spacebar one time, and the button becomes enabled again, and I can save it. And I have yet another, what looks like a blank task in there. Let's try another test case. I'm just going to do a single character, the character C, and save. You can add single character tasks. And you may find, as you're doing manual testing yourself, you start to play around with different scenarios, different things users should or shouldn't be able to do. And this exploratory testing, where you're exploring the different strange behaviors that we maybe want to prevent, this is all part of manual testing. So let's go ahead and expand our logic in the text change listener to improve our app even more following this exploratory testing. So I'm going to comment out that line for now. And above it, I'm going to try and write some more code to say is valid input. And I'm going to make this equal to, well, I want to keep the check for if it's empty. So definitely we want to make sure it's not empty. It's valid if it's not empty. But unfortunately for us, a blank space is neither null nor empty. A blank space is a character. So we need to do something with this code to take whatever the input is, but to get rid of all white spaces, especially if it's only white spaces. Okay. So a quick Google of this, Kotlin, get rid of white spaces in a string, you would probably find there's a useful function that you can call on any string or editable called trim. Okay, this could be null, so I'll do a safe call. And when I command click on the trim function to see what it does, it says it returns a subsequence of this character sequence having the leading and trailing white space removed. Perfect. So if it starts or ends with a white space, or indeed if the thing is only white space, it will remove all of that. I'll close that down. So we can now say input, safe call, trim the white space, another safe call. Actually, we don't need a safe call. We can call is null or empty on something that can be nullable. And inserting this little trim thing here improves our code. So I'm going to copy that and put that for is valid input. Input safe call dot trim to get rid of any leading or trailing white space, and then is null or empty. We can uncomment this line and now say the is enabled equals our valid input. I have put a deliberate mistake in this. Let's test our code now by running the app to see and find this mistake. Opening the dialog. Well, the button starts off disabled, that's fine. And I start to type. Oh dear, it remains disabled. And when I delete the characters, it suddenly becomes enabled. So it seems to be working backwards. Can you think why? I forgot to put the not operator, the exclamation mark before this. We need to reverse this boolean. So it's valid if it's not null or empty. Okay, can run it again. Opening the dialog. It starts off disabled because of line 47. The is enabled equals false. The text change listener hasn't run at all yet. And now I type some normal letters and it becomes enabled. Fantastic. I delete them. It becomes disabled. And if I only do spacebars, it remains disabled. So our manual testing uncovered a potential user experience bug, adding tasks that seem blank because of the spacebar, and the .trim function, that solves that one. However, I can do a single character, A, and I don't really like that. I'm going to demand that the users have at least 2 characters so we can improve the function further. I'm now going to extract this check to a function. So rather than doing all of this logic, these complicated save calls, not operators, trim functions, null or empty functions, rather than doing that all in one line inside our text change listener, I can improve the quality of our code and separate this to its own function. So I'm going to select just the logic, not the variable, only the logic part. I'll do Control-Alt-M, Command-Option-M, and I'm going to call this is input valid. And if I scroll down, that's put that here. It's made a one-liner. It takes an input editable and it returns a true or false. I can do Alt-Enter, Option-Enter to put the return type explicitly. You can see this function returns a Boolean. So now, rather than making a variable, I can just do something like that. The button.isEnabled state equals is input valid, that function. And we can get to work here. I'm going to click on the equal symbol to Alt-Enter, Option-Enter, convert to a block body, just so we can see what we're dealing with. So we need to do two checks. First of all, we're saying it's valid if, after trimming, it's not null or empty. But there's another check. We need to check that, and then if it's not null or empty, check the size of it. Now, you can chain multiple Boolean logics together. To do and, it is the ampersand symbol twice. That is the Kotlin way of saying and. And then we can do a second Boolean check here, something else that could be true or false. True or false. So we can do input.length being greater than 1. However, input could be null, except we've already checked that it's not null. So this is one of those rare occasions where we can do a non-null assertion. After all, it's only valid if this is true and this is true. Well, we already know it's not null or empty, so we can be safe that it is not null. We can assert that it is not null with a non-null assertion. And so now, when we run the app and make a new dialog, if they do a single character, they still don't get save, but when they do 2 or more, then the save button works. I'll just delete some of these junk tasks, the blank ones, and I'll leave my double S for now. So through manual testing, we've explored, we've tried some different test cases, and we used it to improve our code. We extended the Boolean check, this conditional logic here, to add another test case with and, so it's only valid if, after trimming it, it's not null or empty, and if the length of it is more than 1. And we then went back into the app, we ran it again, and we tested it again to make sure it works. But if that's manual testing, then what's the other kind of testing? Why is this term testing such a big deal in software development? What are people talking about when they want to see unit tests or integration tests? And so now is the time for us to look at the programming concept of testing in software development. And let's do that next. Time for another programming concept, this time on testing. No doubt we understand the word, what it means to test something. Lots of testing. Make sure. Manual testing is a legitimate that exists in first we've already covered. Manual, making sure you see what you expect to see. The code works as expected. We can test that the code we've written works by launching the app. We can also test that the code we've written works by writing some other code and doing some checks. It looks like it's worth, obviously. We want a bit of time. So in the case of our add task dialog, we've written a little bit of complex logic there. We maybe predict that that's an area which could be susceptible to mistake using code. It might be a runtime exception, like a null pointer exception. The app builds and compiles fine, but when you go to a certain screen, there's something problematic in the code, and only when the code runs, only when the code is exercised, will that problem reveal itself. This can help to surface crashes before they hit our users. So whether that's manually going to every single screen in the app, or whether that's writing code that makes as much of the code that you've written in the app run, the idea of exercising the code base so those lines execute before happening for the first time in front of our users is an incredibly valuable thing. You might later on hear the term coverage, code coverage, and what that means is how much of your code have you ran in your tests before releasing it to your users. And a third strong reason for testing is to protect against future changes. You might have a desirable behavior, such as with our add task dialog, that they can't add blank tasks, that they can't add a task with only one character. You might desire that the save button is not enabled in those cases, and so you want to prevent a desired behavior like that from breaking when the code evolves. You may in the future do a piece of work which touches that code, and if you have tests in place that confirm how it should work, well then that test becomes the contract for how it should work. And if you accidentally play around with that, you might remove the trim function because you've forgotten why you included it, or you might change the .length to be a different number, or you might even remove it. Well then those tests you have will fail, which is a good thing. It will let you know, hey, you've broken something that we want to work. It takes early to exercise the codebase and to protect against future changes. And notice when describing these 3 strong reasons for testing, I didn't mention manual tests or test code. In theory, as long as these tests are being performed every time, it doesn't really matter. Both can help in these 3 areas. However, we've seen manual testing in the previous tutorial, and indeed throughout the course whenever we've ran the app. But let's talk now about test code. So, what does test code look like? After all, we've been writing lots and lots and lots of code throughout the course, code that makes our app run, code very much. Imagine you've made a calculator class. You've written some code, and that calculator might have add, subtract, all the various calculator operations. Test inside a class called, we give it a slightly more complicated names. This class, we then perform the operation we want to test. And indeed, if I do calculate, assert, confirm, code really is. As long as you're fully testing the code that does that, here, it's exercising the code base, all of the code in the add function of our calculator. That code will be running, so any null pointer exception or any serious problems that could happen at runtime, we add function in the future and make a mistake, we have protection because this test would fail. And as long as we're running these tests, we would be notified that this test has failed. Don't be confused by some new syntax like the test class or the annotation with the word test, or this assert equals thing. The principle is very simple. Write some code that will automatically check the things you want to check. And so, to put this entire concept into immediate practice, let's go ahead now and write some test code. Time now to write our first ever test. I'm back in Android Studio and I've closed down every file, I've closed down my emulator, we won't be needing that for our test, and I just have the project pane open on the left. Before we dive in now, I just want to say a couple of things. The idea of writing tests in code, I remember, can feel really intimidating. I remember not fully understanding the point of it or the value, although hopefully the previous tutorial helps a bit with that, and it just felt to me when I was a junior Android developer like a really abstract, weird thing, and I had no idea what it looked like or what a good test should be, but I'm here to show you really how simple it is. And the second point of note is, we're likely not going to spend a long time in the rest of this course writing a ton of tests. Right now, we're not working on a big team full of other engineers for a production-grade app. However, the concept is still really important, and it is going to segue beautifully into the concept on architecture when we start to talk about cleaning up our code, organizing it, separating it, putting things in places where we can even test it in the first place. So, trust me, it all relates. It's all part of the bigger picture of this section. So, lucky for us, in most projects, Android Studio goes ahead and gives us the necessary dependency and even gives us a couple of example tests. Let me show you where these tests are and where we need to go to write our new tests. In the project pane, with our Get It Done project at the top, I have the app folder. So if you open that up, so far so good, we know our build file, and then the source folder. We'll go ahead and open the source folder, and we'll stop there. Now, up to this point in the course, we've been working in the main source set. All of our code is inside either the Java folder or inside the res folder for the resources. But now, the previous tutorial I mentioned, there's two ways to test in mobile app development, manual testing and test code. Well, now I'm here to tell you that when you write test code in Android Studio, there's broadly speaking two categories of test code. Code that runs on the JVM, the Java Virtual Machine. That basically means like the command line, these tests will run very quickly. And then there's tests that require an Android device, whether physical or emulator, to run. The one that says test, and for me in brackets it says unit test, these are the very fast ones that run on the JVM. And then Android test are for tests that run, or they need to run on an Android device, such as an emulator or even a real phone. For this section, we're only going to be focusing on these unit tests. Short, small tests that run very quickly. Some of the using up the test folder. And for me, all other folders opened up, Java, the package, and then hopefully in new projects, Android Studio gives us an example unit test. So let's go ahead, double click this to open the provided example unit, the host. That's a complicated way of saying the JVM, which is a complicated way of saying these won't run on an Android device, they will run on our computer, on the command line, very quickly. I'm going to go ahead and put the function in a bit of space, so some line breaks above and after. We have a wrapping class, and this can be called anything at all. This doesn't really matter. Typically with the testing framework, which is a thing called JUnit, you need to have your test inside a class, but the class name doesn't matter, so usually you give it a meaningful name. In this case, I've just called it an example unit test, and then our tests are the functions. And let's look at the example test. Test, addition is correct. Assert equals 4, comma, the expected outcome, and then the actual outcome, 2 plus 2. And we can run this test right now by clicking the little play icon next to this test. So I'll click this and I will click run, the top one, and I'll wait a moment. The run pane pops up and the tests will appear on the left-hand side here. The first time you run these, it may take a moment or two, so I'll just pause until they're ready. And then I have test results, and then I have a green tick. Tests passed, and once Gradle got up to speed, that test took 3 milliseconds. Unit tests that run on the JVM, the Java Virtual Machine, on our development computers, they run incredibly quickly. Now, we don't have much information other than all of our tests passed, all one of them, one of one test you can see there, but you can click the little tick icon, and that will show you all of the individual tests that passed. By default, you would only see the ones that failed. So let's go ahead and click this tick icon, and then we can see all of our tests passed, all of the tests in the example unit test class passed, and then the test addition is correct passed. So let's quickly now go ahead and write another test. So we'll make a new function. You must give it the test annotation, so @ test, and you can autocomplete, you see that one there, org.junit, and we'll do fun subtraction underscore is correct. And this time, rather than doing it all in one line, we'll break it up a bit into the action and then the assertion. So I'll do a comment to say perform an action, and then I'll do another comment down here to say assert the result. That's typically how we want to think of these tests. Do something and then verify that the outcome is what we expect. So under the comment, we'll do a new variable called result, and that'll be equal to 7 take 3. I should auto-format that to put the spaces in. There we go. Result 7 take 3, and then underneath, we then assert what we expect to see. So we will do assert equals autocomplete. So we expect this to be 4, and then we provide what we actually got, our result. You know what, I'm going to make this 7 take 2, and then 5, so we're not just doing 4 all the time. And I'll go ahead and run this one test here. Well done, you've just written your first unit test. Subtraction is correct. Now we only see that one function there, but we can actually click the play icon for the entire class, and then all of the tests in the class will run, and we should get some more useful output. So let's do this. We'll run the example unit test class. Those two tests in total took 3 milliseconds, and we can see all of the things that passed. Addition is correct. Subtraction is correct. Let's intentionally now fail this test by making the answer wrong. Let's say expected 6, even though we know the result will be 5. And let's run all of the tests again. So we'll run the whole class. And look how useful that is. We get confirmation that the addition test is correct, but the subtraction is correct test failed. We expected 6, and we actually got 5. So failing tests aren't immediately a problem. They give us useful information. And if we write good tests on our code base, they can provide some confidence when things go wrong, and they can make it very, very quick to find out where it went wrong. Now, I'll just go ahead and close the run pane for now to give us some more space. And I'll put this back to 5 to make sure it works okay. And I'll rerun that test, just so everything goes green again. Good. So at the moment, these tests aren't particularly useful. And why aren't they useful? Well, the only thing they're asserting is the code in the test itself. You would never typically write tests like this. Tests are to test other code that actually exists in our main source set. We will look at testing code in the main source set, code from our real project, in the next tutorial, but for now I want to show you how you might go about setting up a test where you are testing some other code, and by doing that we will make a quick class underneath this example unit test right here. So make some line breaks, and we will do class greeter. Our greeter class, it will do a very specific thing, and we will have one function that says greet, and we will greet a name. It will return a string, and we will simply return hello, comma, name, with an exclamation mark. So imagine now this greeter class is some real code that we've written in our projects. We have a welcome screen, and when we've been playing about with manual testing, sometimes we've seen typos, sometimes we've been forgetting the exclamation mark or spelling hello with only one L. So we've decided to extract the code that greets the user to a little function, and rather than having to continually manually test it, we figured, you know what, let's write a unit test, a small bit of code that confirms the output is what we expect, and then we never really need to manually test that feature again. It's happening automatically. This would be a common use case for a unit test. So let's now go and write a proper unit test where we're testing something external. So one more test. Symbol for test, very important. If you remove that, you lose the ability to test it. Okay. So test, and we will do greeter, the thing we're testing, and then underscore greets person correctly. Now these unit test names can be anything that you like. They could even be, you guessed it, cheese. Okay, doesn't matter. What does matter is that if it passes or fails, and you see the function name that fails, that you as a developer have enough information in that function name to know what went right or what went wrong. Okay, so there's various formats that people like to do this. I like to do the thing that I'm testing, an underscore, and then what I expect to happen. So I'm testing the greeter, and I expect it to greet the person correctly. So again, let's perform an action. So this time, we need to set up our greeter. So our greeter equals a new greeter, and then we will do a variable to capture the result, greeter.greet vin. So that's the action. We've performed it. We've called the greet function. The action has happened. But now we need to assert the outcome. So we will assert the result, and we will do assert equals. Now what do I expect to see? I expect to see hello, comma, vin, exclamation mark. That's the expected, and the result is there. So let's run this test, a real unit test where we're actually testing some code that is external to this test. This test now has more value than the previous two. Let's run this. And all is good. The greeter does greet the person correctly. If I close the run pane, and let's say in my app, in my production code, in the real stuff that we're writing for our app, I make a mistake, or a developer comes in and changes it, well then this unit test now will fail. And when I click the test here, we expected hello vin, we actually got helo, 1L, however you pronounce that, vin. And then we can go look at the failed test and then fix the bug. So congratulations, that is writing your first test code. We've written a couple of tests. These top two don't really serve much purpose because we're only testing the thing inside the test itself. But this last test, if I just run it again to now pass it, this is pretty close to the real thing that developers do when they write unit tests. They perform an action on some real code that we've written in our projects. They capture the output and they make sure it equals what they expect it to. And I'll just round off this tutorial with one final point. These tests, as I've been referring to throughout the tutorial, are called unit tests. Well, what's a unit? And the answer is, it's a fairly abstract term. It's the smallest possible thing, the smallest bit of code you can test. It might be a function. It might be a class. It's an intentionally abstract term, and a good way to think of it is like Lego. If you are building something like a house out of Lego, well, your units might be the bricks, and the overall house might be your app, your project. If you're testing that each brick is strong, each small bit of code, each small action in your app, if they all pass and are strong, then the overall project, the overall house will be strong. So there's no specific answer to what a unit is. A unit is whatever is a single piece of behavior to you, the developer. In my case, this greet function is a unit. It's a small bit of behavior that I want to test. And in our Get It Done project, a similar unit might be the small bit of code that checks whether the add task title is valid or not. And so with that, let's now apply this new concept of writing a unit test to the real project. And we'll do that in the next tutorial.